Hello, fam. This is the second part of our standard normal curve or standard normal distribution lesson. The first part of this lesson was really long. I'm thinking that this part will be much shorter. So last time we talked about the basics of our standard normal curve. What makes it different than just our normal curve, because remember, this is our normal curve. A normal curve can have any numbers across the x-axis. So here we go from 55 to 145, 81 to 99, 1 to 43. A normal curve can have many different values on the x-axis, and we are limited to determining how much data is between or within 1, 2, and 3 standard deviations. A standard normal curve is always 0, 1. So the x-axis is always 0, 1, 2, 3, and then -1, -2, -3. And to find areas for this type of normal curve, we need this z-table. So we talked about last time how to find an area, a percent, a proportion, or a probability. Those are all the same thing if I give you a z-score. So last time I gave you the z, you gave me the area. This time I give you the area and you give me the z. So you are going to work backward. You are going to look inside the table and then match that up to what z it belongs to. So using area to find z-score. So we're working backward. Example, find the z-score at the 90th percentile of the normal standard curve. So I'm going to do some highlighting here. The first thing that they're asking us for is the 90th percentile. So we use a z-table to find the value of z from the standard normal curve that is closest to the given percentile. Closest. So this distinction of closest is really important. You will find that when you are given an area, very rarely does that area show up nicely inside the table. So let me explain what I mean by that. So we know that the 90th percentile translates to the z-score at which 90% of the data is less than or equal to it. So now let's convert that to a decimal. So you either move the decimal to the right twice or you divide by 100. That's going to give us a decimal of 0.90. Now to make this a little bit easier for myself, I'm going to change this to 0.9000. Why? Because inside my standard normal table, all of our areas are given to 4 decimal places. When I go into the standard normal table now, and I try to look for 9,000, you can look on this entire paper and see, are any of these nice areas like 1,000, 6,000, 650, 7,200. If you look at all of these areas, hardly any of them end in a 0, 0. All 4 digits, ooh, I found one, 6,700. That's pretty rare. This is why the notes say you need to find the area that is closest to 9,000, because there will not be 9,000 in this table. So we go inside the table and we want to start looking for where the 9,000s are. So I can start up on 1.2. I got a bunch of 89s, and then toward the end, I'm starting to get 9,000s. And then the row below it, more 9,000s. So just like when we first learned the standard normal curve, what I have here is a snippet of this table. We don't want any on this top row because that's 87, 88, 88, and we're looking for 9,000. This one is 8980. So that means that this guy is 20 away from 9,000. 8980 is 20 away from 9,000. 8997 is 3 away from 9,000. And the next one is 15 away from 9,000. So even though these are decimals, I think about them as a whole number. I think about them as a thousands number, and I find the one that is closest. So of these options, the one that is closest is 0.8997. He's only 3 away, or 0.0003 away from the desired area. So this is as close as we're going to get. So to find the z that matches that, we go over to the left and up. So we're going to build our z based off of those numbers. Then we are supposed to sketch a standard normal curve with the value of z marked on the axis. So luckily we already have that written here for us. Here's our curve. We've marked an area of 90 to the left. What z is closest to this? A z of 1.28. Where am I getting that from? Over here. I have a 1.2, and then on the end, I put an 8. So this is the method every single time they give you an area. So 90th percentile would be an area of 90%. The next one they want us to do is the 75th percentile of the standard normal curve. So 75th percentile, or I guess I could just write this underneath. 75th percentile is equal to 75%, which is equal to 0.7500. Or actually, let's just leave it as 0.75. And then underneath that, I'm going to write mine as 0.7500. Because when I go to find this in this table, I have 4 digits that I need to compare it to. So I changed this to 4 digits. So this is another snippet of the table. I'm looking for the closest to 7,500. So this top row, not going to be close. 71, 71, 72. Middle row, we got a 74, 75, 75, and then bottom row is too big. So we're going to concentrate on this middle row. 7486 is 14 away from 7,500. 7517 is 17 away from 7,500, and the last one is 49 away. So of these options, the first one in the middle row is the best. How do I know the distances? I'm just computing it in my head. So if you needed a math formula for this, you could do 7,500 subtract 7,486. 7,500 subtract 7,517. 7,500 subtract 7,549. That will give you the distance away. This one would end up being negative 17, and this one would end up being negative 49, but you can't have a negative distance. So I'm just doing them in my head, but if you need a mathematical way of doing it, just take the number you're looking for and subtract the numbers that you think are close. Okay, so this now gives us a z of 0.67. 0.67. So now we have to label our curve. Luckily, it's already got the 0, 1, 2, 3 for us. So positive 0.67 is going to be about right here. Holy moly, teacher, get a grip on your flag. We label z equals 0.67. We shade the curve. And we can label this as having an area of approximately 75%. If we're rounding, that's approximately 75. We could write 7486, but that would round up to 75. If we wanted to, we could also label this as the 75th percentile. Okay, next up is the 20th percentile. So I use the same pattern for all of these. 20th percentile translates to 20%. That translates to 0.20. And that all translates to 0.2000. Okay, I'll draw my standard normal curve. And now I will go to my blue table and start looking for 2000. So I'm going to pause. You pause and you try to find where it's at. You don't have to write the z yet, but you start looking in your table to figure out where it's at. For the 20th percentile, you should be on the negative side. So if you flip to the negative side, and we start looking for 20, well, here's 18, 17, so those are getting smaller. 21, 20, so it's somewhere on negative 0.8. So I work my way down. This is 61 away, 33 away, 5 away, 23 away. So it's going to be this 2005. That's going to give us a z-score of negative 0.84. Negative 0.84. So z equals negative 0.84, shade in our area, and you could label the percentile if you wanted to. It's not required, but you can. Okay, last problem. Says 45% of all observations are greater than Z. So we got to be very careful to acknowledge that this says greater than. Forgot to do one thing here. I did not label my area. Sorry about that. Okay, so let's think about this. 45% of the observations are above Z. So if 45% are above, then 55% are below. You just do 100 minus 45. So 45 are above, then 55 is below, which means we are looking for 55%, which is the same as 0.55, which is the same as 0.5500. I'm going to draw my my standard normal. And now I'm going to go into my table and try to find the Z. Okay, pause if you have not found it yet. Pause if you haven't found it, because you need to find at least one on your own. Okay, I am getting a Z of 13.13. So I go over here to plant my flag. I can label it Z equals 0.13, and now I shade in the desired area. The Z-score that has 45% above it is the same Z-score that has 55% below it. So for our next lesson, we're going to bring this all together. We're going to combine me giving you the Z-score and you giving me the area with me giving you the area, you giving me Z-score, relating to real-world problems. So now we're going to bring it all together and see how we actually use it for statistics and how we use it to answer questions. There is no can you do or check for understanding that goes with this. We are going to build the can you do and the check for understanding and all that into our next lesson. So you're going to practice using area to find Z-score in our next lesson that we're doing. Okay, that's it. Love you guys.